Okay, so today I will show you how you can create those nice looking robot eyes using this round display. Actually, those are two displays driven by this ESP32 board. And I have to say that initially I had quite different plans with this display. When I saw this display module, I thought I might use it for some car gauges, but as many times before, I did forget to check the size of the display. And even when the actual resolution of those displays is quite decent, each display has the resolution of 160 by 160 pixels, as you can see they are just very tiny. And don't get me wrong, they look great, but if I would use them for some gauges, it would probably be for some RC car, not for a real one, but please let me know in the comment section if you would like to see something like that. Anyway, back to our robot eyes project. I'm not quite sure how visible it is on the camera, but there are 3D lenses on top of those displays, which makes it even more interesting. They are catching those highlights and it looks very real. It looks like that those displays are actually 3D. Just for the comparison, here is the very same display, but without those lenses applied. There is a double-sided tape on those lenses, so you can decide for yourself if you want to apply those or not. So let me show you how you can create this very same project. Before we start, I need to talk about two things. First of all, I've just released a video about the Dasai Moshi project, which also has the robot face, but that project is using the monochrome OLED display. The second thing that I want to talk about is a sponsor of today's video, which is PCBWay. And that's because if you are making electronic projects, sooner or later you might need PCB or PCB assembly or SMD stencils, and PCBWay has you covered. They offer all of those services for a reasonable price. On top of that, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay, and let's get back to our video. Again, we will be using this display module, which is called the 0.71-inch DualEye round LCD display module from Waveshare. And to drive the display, we will be using the ESP32 board. This one is called ESP32C30 and it's also from Waveshare. And the reason why I am using the ESP32 board from Waveshare is quite simple. If I open the documentation for the display module, the connection listed in here is for this particular board, being the ESP32C30. So let's actually start with connecting the wires between the display module and the ESP32 board. We have the VCC and the ground pins for the power supply, and then each of the display has the SPI connection, which means that it needs the data in, the clock pin, the DC, which is the data comment pin, and the reset pin, and you can see that the data in as well as the clock pin are shared between those two displays, but we have two separate chip select pins. So when the chip select 1 is low, the data is being sent to the first display, and when the chip select 2 is low, the data is being sent to the second display. We also have two different BL pins which are for backlight, the backlight 1 and the backlight 2. So let's connect the display to the ESP32 module in the very same way. On the display side, you just snap in this provided connector, and there is only one correct way how to do that. On the ESP32 board, I found it actually easier to not look at the table of connections, but rather take a look at the image and trace those colors. And yes, the black wire is in here twice, but if you go from top to bottom, it should be probably fine. So with everything connected, it should look like this. Which means that it's time to jump to the Arduino IDE and upload some sketch. But actually before we do that, let's open the documentation again. There are some steps in here which we need to follow. First we need to download and install the Arduino IDE, which is something that I've already done. And then we need to install ESP32 boards. And you install the support for the ESP32 boards into the Arduino IDE by going to File, Preferences, and then inside here or clicking this button, you add this line, this URL, and then click the OK button and open the boards manager, which is this icon, and in here type in ESP32 and click the install button next to the ESP32 boards by Espressif Systems. I already have this installed, so let's just jump back into the documentation again. And the next step is to install some libraries, but there is a note saying install offline, which means that we should not go into the Arduino IDE and install the library from here, but rather we should download those libraries from this demo zip file. So let's just download the demo zip file. And this is the content of the zip file. There are some libraries and some Arduino example. So let's start with the libraries, and I think that we only need to install the TFT ESPI library. But in order to install it, we need to manually copy it into the Arduino IDE folder. And those libraries are usually placed under the documents/arduino/libraries. And I already have some version of the TFT ESPI library in here, so just in case I will just delete it. And then I will copy and paste this TFT ESPI from the downloaded zip folder. I don't think that I need the animated GIF example, so that's all that I need, and then I will jump back into the example folder from the demo folder, and there is this main sketch which I will open in the Arduino IDE. Before we can upload this sketch to the ESP32 board, we need to select the correct board, so go to Tools, Board, ESP32, and the one that should be selected is all the way on top, called ESP32C3. If I jump back into the documentation, there are some things that needs to be set. So let me just put this aside, and the USB CDC on boot should be enabled. Then the flash size should be set to 4 MB, and the partitioning scheme should be set to a huge application, because I guess we will have a lot of images, a lot of data, so we need as much space as possible. So huge application for the partitioning scheme. And let me just double check that everything else is the same, which seems to be the case. Which means that the only thing left to do is to connect the ESP32 board to my PC using the USB-C cable, and then jump to Tools, Port, and select the correct port, which in my case is communication port number 9. After that, we need to click the Upload button to compile the sketch and upload it to the ESP32 board. And unfortunately, we see some errors. This is kind of strange because we are using the very same settings inside the Arduino IDE, and we are using the custom TFT ESPI library from that demo zip file. On top of that, we are using the very same board, being the ESP32C3, so we have to take a look what might be wrong. And when I look at this step, the Install ESP32 development board, it says that the recommended version is 2.0.12. If I open Arduino IDE and open the boards manager again, and again type in ESP32, you can see that I have the latest version installed, being the 3.1.3, and I guess that this might be a problem. So let me just jump back into the 2.0.12 and install this version instead. And after the latest version is uninstalled and the 2.0.12 version is installed, let's try to compile the sketch one more time. So click the Upload button and see what happens. And we still see some problem, but that's only because when I've installed a different version of the ESP32 boards, our settings was lost, so we need to again go to Tools and set the USB CDC on boot to be enabled. The flash size should be 4 MB, and the partitioning scheme should be set to the huge application. So let's click the Upload button one more time, and hopefully this time it will work. And indeed, now it finally compiles and uploads without any problems. In the beginning, it shows some creepy human eyes just looking around. And I believe that then it switches to a different set of eyes, more like the animated robot kind of eyes, I guess. And then there is this third section where one of the eyes stays the same, but the second one is different. And finally, there is this solid color fill, one eye being red and the other one being blue. So there are a lot of different images, a lot of different animations, so it kind of makes sense why we needed to switch to the huge app partitioning scheme for this sketch. I would like to actually simplify this sketch as much as possible and only show one static image. I mean one static image for both displays, so let's just try to do that. Unfortunately, this sketch is slightly complicated because it's a combination of multiple different sketches. So what I found works the best is to just comment out some piece of code. For example, let's just comment out this structure out. Maybe like so. And then try to compile the sketch and see what errors we are facing, if there is anything else that we need to remove from the sketch. And here you can see that inside the setup function, we are using some of those functions. So just comment out this piece of code as well. And continue like this until we have just a bare minimum of code. I don't think that I need many of those additional files, so just click the three dots menu and delete it from the project. I don't need this file and probably not even this file, so just delete it, this one as well and this one as well. Probably this one as well, I don't need it. Not quite sure about this one, just keep it for now. And I probably need those two because they are those images which I would like to show in the beginning before I delete them. And the wiring just includes comments how to connect the display to the board. So let's just try to compile it again. And yet there is one more function which is not present in our sketch. So again. And now it compiles without any problems. However, before uploading it to the ESP board, I would like to do something. For example, light up one display with the red color and the second display with the blue color. And something like this is happening here in the main loop. We are setting the rotation for one display and then filling the screen for the second display. Let's adjust the code slightly, so when the chip select pin is low, we are talking to that display, the display B, and we will set the rotation to 0, so no rotation, and fill the screen with some color. So just copy the piece of code in here, and we have some color definitions up here. So for the first one, let's use a blue color, so fill the screen with the blue color. And then set the chip select pin back to high. And do the very same thing for the display A, so set the chip select pin to low. Then set the rotation and fill that second screen. But this time we will use a different color. Again, I will borrow some color definitions from up here, so for example the red color. And I will use it to fill the screen. And then we want to set the chip select pin back to high. I think that this is wrong, it should be high, not low. After that, we can wait how many seconds we want. Let's just wait, for example, 20 seconds. Because all I want to do is to see if I can fill each of those displays with different colors. So with the sketch like this, let's try to upload it to the ESP board. And once this is uploaded, we can see that one display is red and the second display is blue, so it seems to be working. The logical next step is to not just show some solid color, but instead try to display an image. And I guess for now, we don't even have to create our own image, we will just use whatever is already inside the sketch. As you can see, I'm also switching the display to use the one without those 3D lenses, because even when the 3D lenses look great, they are distorting the image, making it slightly harder to see what's going on. So let me just remove those protective stickers and we can move on. And we have quite so many images inside those header files, we just need to draw them, and thankfully there was this section which was called, let me see, it was called Demo2. And I think that this section was for drawing individual images, so just copy this piece of code and go inside our main loop. And when the A equals 2, I want to draw one of those images. So first set the chip select low for one of those displays, draw the image and then set the chip select high. And then set the chip select low for the other display, draw the image and set the chip select high for that display. And I guess let's just wait after we draw those images. And let's not wait that long after setting the solid colors, so maybe only wait 2 seconds after setting those solid colors. And then we will draw this same image on both displays, being this G-image A1, which I guess is in here in this i.h header file. So with the sketch like this, let's try to upload it to the ESP board. And sure enough, we see solid colors for 2 seconds and then some sort of image, some sort of robot eye, the same image on both displays. I think that the next step is obvious, we want to draw our own image. But for now, let's not use the eye image, but rather some test image, some test patterns, so we can easily see any possible problems. And yes, as always, there will be problems. So let's just jump into Photopea. And Photopea is a free online graphic editor similar to Photoshop. And in here we will create a new file in the same resolution as our display, which is 160 by 160 pixels. Hit the create button, and then we can draw whatever we like. Let me speed it up a little bit for you. So I will first visualize the circle area of the display, and then add some simple black and white checkerboard patterns in the different sizes. It might be a good idea to also add some gradients, the black to white and also the rainbow one. And just in case, I will also add some solid colors. Finally, let's add something which is not a rectangle, for example, some label. And I think that this should be enough to spot any possible problems. Let's rename this file to test image. And then we need to export it as a PNG file by going into File, Export as PNG file. I will keep the default settings and just click the Save button. That will save the PNG file. But to use it on our display, we need to first convert it to the C code. And if we take a look at the current image data, it looks like that every single pixel is being represented by 2 bytes, so 16 bits. So it looks like that the file format being used is the RGB 565. 5 bits for the red channel, 6 bits for the green channel and 5 bits for the blue channel, which is quite common color format. And the online tool that I usually use for converting images into the C code called Image to CPP does support this file format. If we jump to the draw mode, we can switch it to the 2 bytes per pixel, the RGB 565. So let's just do that and then select our image, so choose our image. We see the preview of the image and then we can click the generate code and copy the output. Inside our code, we don't need those current image files, so just delete everything and instead paste the content from the Image to CPP website. We don't need this helper array, but we do need to know the image name, which is this one, EPB bitmap test image, so just copy this into the clipboard. And inside the main sketch, use that image name when drawing those 2 images. So this is the image name for first display and the same image name for the second display. After that, let's again press the upload button and see what we get. And we do see our image, but it looks kind of wrong. I mean, the black and white checkerboard patterns, they are perfectly fine, but anything that has to do with color is kind of strange looking. For example, the very first rectangle is supposed to be red, but instead it's dark blue. And we can actually look at those color values if we use some RGB 565 color picker. For example, this one, so we know that the red color has the value of F800 for the RGB 565 for the 2 bytes per pixel. But instead we are getting some dark blue color, maybe something like this. And here you can see that the color value is 007F or something like that. And if you take a closer look, this is just the reverse order of those bits inside the byte, so all that we need to do is to just switch the byte order. And while there is this checkbox in the Image to CPP website called Swap Bits in Byte, that will unfortunately only swap bits inside a single byte, so it will just swap those 2 bits and those 2 bits, but we need to reverse all the 16 bits at the same time, which means that we need to use a different tool for converting the image into the C code. And there is a tool called LCD Image Converter, which is free and open source, so we'll just download this tool and run it. And I will open our PNG image, and we want to convert this image into the C code, and for that we need to set some options by going into Options Conversion. And the color format that we want to use is the RGB 565. I think that the scanning direction is correct, going from left to right, top to bottom. But inside the Image tab, we need to set the block size to be only 16 bits, and change the byte order to be big endian. Then click the OK button, save the changes. And we can export the C file by going to File, Convert. Then select the file name, I will actually use the .h extension and click the Save button. Then we will add this file into our Arduino sketch by selecting Sketch Add File. And of course locate the H file and click the Open button. That will add this file into our sketch, and you can see that we have some kind of preview of this image in the Arduino IDE. This is commented out, so it will not be included in our sketch. It's kind of nice. But I don't think that we need to include this H file, and I think on the very bottom of the image we don't need this constant. The only thing that we need to know is the name of the image, which is this one, image data test image. So we will again use that name inside our main sketch, so just use that name. And then we don't need this header file anymore, so just delete it from the sketch, so delete it. And delete the second I file as well. And then back inside the main sketch, we don't want to include that header file, but instead we want to include our testimage.h file. And with all the changes done, let's upload it to the ESP32 board. And now the test image looks correct, including all the colors. As you can see, those two displays are mounted in a way that those connectors are in the middle, which means that those are rotated in a different way. So even when we show the very same image, on one display it's being rotated by 180 degrees. And because in the Arduino code I have seen some functions to set the rotation of the display, let's try to play with those. In here we have the set rotation for the first display and for the second display. And 0 is no rotation, 1 is 90 degrees, 2 is 180 and so on. So we should rotate one by the 90 degrees and the second one by the 270 degrees, which corresponds to the number 3. And then let's try to upload it again. And while the images are rotated, they look wrong again. The colors are correct, but there is some kind of ghosting. You can see that those edges are kind of blurred in a way. And unfortunately, I wasn't able to solve that problem, so I'm hoping that maybe someone out there knows the solution, and if it's you, please let me know in the comment section. What I will do for now is to just not use the rotation of the display, and if I wanted the image to be rotated, I will rotate the image file instead. That unfortunately means that I would need two sets of image files if I want a different image for the left and right eye. So let's finally create those robot eyes images. And I will cheat a little bit because this time I will be using AI image generators. And for no particular reason, I will try this page, which is the Deep AI, and I will actually not start with the AI image generator, but instead I will start with the AI chat. And in here I will say create me a prompt for the AI image generator to generate some robot eyes. Something like this, and click the go button. And that will hopefully generate me some prompt, so I'll just copy this prompt and use it inside the AI image generator. As for the preference, I will probably go with quality and then click the generate button. And after a few seconds, we have the robot eyes, but actually two of them, so let me just try to click the generate button one more time. And we are still getting two eyes. This is kind of strange, so let me see eyes. Okay, not eyes, but just one eye. Let's say single robot eye. And I think that something like this looks much better, so I will just download this image and then keep clicking the generate button to have a few more of those. Again, download this one and click the generate button again. And this looks quite nice. So again, download this one. And if we want, we can maybe add some more colors. So maybe also include some yellow color and click the generate button. And this looks nice, but unfortunately it's not from the front view. So let's just click the generate button again. And this looks also quite interesting, so download this one. If we want, we can also click the styles button and maybe choose some style, for example the cyberpunk. But I don't think it will make too much of a difference because we are already getting cyberpunk style images. Okay, and I think that this should be enough. And after a little bit of clicking, I have about 30 or so images of robot eyes. However, those are sized 640 by 640 pixels. And we need those in the resolution for our display, which is 160 by 160 pixels. So for that, I will again jump to Photopea. And in here, let's again create a new file in the resolution of 160 by 160 pixels. And hit the create button. And then just drag all of those images inside our file. As you can see, upon importing, they were automatically adjusted to the size of our canvas. So resized to fit the canvas. But this transformation is actually non-destructive because this small icon shows us that those images are actually smart objects. So if I double click it, this is the image in the full resolution. So what I can do is I can go to Edit, Transform, Scale. And holding the Alt key on the keyboard, I can scale it to be slightly bigger, maybe like this. If I want to visualize what's the area of the display, I can create a new layer. And then I will create a new rectangle and just draw it in the size of our display, 160 by 160 pixels. and then right click and select the ellipse tool and set the mode to be subtract, and then draw the ellipse from, let me see if I can draw it from around here, and then move it with the spacebar to the correct position and draw it again in the very same size as our display, like so. And so now this layer shows the area of the display, so anything that's outside the display will be black and not visible. So what I will do is I will just rename those layers to have some meaningful names. And again, use the scale tool together with the Alt key, so it's scaling from the center, to give it some correct size to look nice on the display. And maybe move it around slightly using the arrow keys on the keyboard or the mouse cursor. And then I will do the very same thing for every single layer. To speed up the process a little bit, you can use a keyboard shortcut for scaling, which is Alt-Ctrl-T. This is actually slightly different from real Photoshop, where the shortcut is Ctrl-Shift-T. Anyway, you can see that most of the time I was just scaling those images to be slightly bigger to nicely fill up the space. But for many images, there was no change needed. As for the names, I ended up using numeric suffix instead of trying to come up with a special name for every single image. And so in the end, we have 30 different eye images. Now in order to export those as individual PNG files, we need to go to File, Export Layers. And you can see that right now we have 0 exportable layers, but that's only because this function expects those layers to start with the -e-, which we don't have. So we will actually uncheck this first checkbox, and then set the format to be PNG file and click the Export Layers button. That will export all those eyes as individual PNG images, including the overlay, which we don't need, and we just need to convert those PNG images into the C code. Same as the last time, the tool of choice is the LCD Image Converter, so I will just open all of those images, and thankfully we can select all of those images at the same time, and then we can go to File, Convert All. But unfortunately in here we have to click the Save button 30 different times because we need to select the file name for every single image. So let me just quickly do that. And we should end up with the C file for every single image. We can of course import those C files into the Arduino IDE, but I would prefer if all of those files were actually inside one file. And a simple way how to do that is to just run the command line batch script. So first press the Windows R, and type in cmd for command line, and then inside the same folder as our images I will type in copy and *.c, so I want to copy all the C files into the robot eyes.h file. And press the enter key, and all those files should be copied into this H file. And we of course want to add that H file into our Arduino project. So inside the Arduino IDE, let's select Sketch Add File. And let's locate our H file, which is this one, and open it. But before we can use it, we need to first remove some elements. For example, this include shouldn't be there, so just copy this into the clipboard, and then select Ctrl-H to replace, and you will to replace this line with nothing, and do it for all the occurrences, so replace all 30 cases. And then if I scroll down at the end of the first image, there is this line saying constant the image robot eyes. And not only we don't need that constant, but the image, I don't think that this is the known name for Arduino. So we just want to delete those lines for every single occurrence. And for that, let's find it first. So constant the image. And then we want to keep searching until the end of the line. And for that, we will use the regular expression. So click this icon. And then type in dot and asterisk to search for every single character. And it actually continues on the second line as well, so the new line, so \n for the new line, and again dot and asterisk to go all the way to the end of the line. And if I use those arrows, I can jump between all the individual occurrences, and we of course want to replace all of them with nothing, so with empty string, and click the Replace All button. So with all those changes done, we now have 30 different images with the name image data robot eyes 01 all the way to, let me see, all the way to 30. So let's just try to draw one image, so I'll just paste the image name in here, the 01. And of course on the top of our sketch we need to include our new H file, which is called robot eyes.h file. And then let's try to upload it to the ESP32 board. And we should see our new AI generated robot eyes on those two displays. However, we have generated 30 eyes and we are only showing one of them, so let's just fix it and show all of them one by one. By the way, I have changed the rotation for both displays back to 0 to not show any visual artifacts. So one of the image is being rotated by 180 degrees compared to the second one, but it doesn't seem to be too much of an issue for the robot eyes, thankfully. At least not for this particular image. So let's try to show all the other images as well. And while we can change the sketch to just copy this piece of code and then change the image name to be 02 and 03 and so on, a better idea would be to create some kind of array which holds the reference for all of those images. And while we haven't used the image to CPP website to generate those images, this tool actually has a nice little feature that will create that array. So let me just change this to be 565 and then just randomly select few of those images, for example those two. And then if I click generate code, on the very bottom of the code there will be this helper array which I will copy into the clipboard and then paste it into the Arduino IDE. And we probably don't need this line, but we do need something like this. And let's rename the array to be robot eyes images. And we have 30 different images. And let's just insert all of those names in there. Going from 1 all the way to 30. And then use this array name inside our main loop for drawing the images. So this is the first image and the second image. And as for the index, I guess we can use this variable called I. So just use the I variable, which goes between 0 and 7. And we should go all the way to 30. And let's just not wait 20 seconds between different eyes, but maybe only, I don't know, maybe like 5 seconds should be enough, or maybe even 3. And let's try to upload it to the ESP32 board. And it looks like I have used the wrong image name. Our image name is actually image data robot eyes 01, not EPB bitmap. So we'll just quickly replace it with the image data, like so. And then click the upload button one more time. And sure enough, we see the red and the blue colors. And after that, we see different robot eyes every 3 seconds. And some of them look very nice, but some of them are not so great. Especially the ones which are not symmetrical, because again we are not using the screen rotation. So those two images are not being displayed in the same orientation. If I find the fix for the problem, I will definitely post the solution into the comment section, so you should take a look if it's already there. If you have any questions or comments, please post them in the comment section as well. As always, all the source files for this project are on GitHub, the link is in the description. That's all for today, thank you very much for watching and I hope to see you soon, thanks and bye.